A modern whale watching adventure is an amazing experience out on the open sea. But if you went looking for whales 48 million years ago, you'd need hiking shoes, not a boat.
This is because whales used to walk on the land, looking like a really big dog. They had forelimbs and hind limbs, they had nostrils really far forward, a mouth full of teeth, not a single tail fluke to be found.
So how did these four-legged creatures become the massively sized filter feeders swimming the depths of our ocean?
It's a wacky tale, and it just might surprise you how much this creature really had to suck in order to become the largest animal ever to live on our planet. Let's rewind to the beginnings of whale evolution. The earliest whales evolved from predatory land animals that looked more like wolves than whales about 52 million years ago during the Eocene.
Over a remarkably short period of time, these creatures returned and adapted to aquatic environments, diversifying into forms like basilosaurids and giving rise to toothed whales,
Odontoceti,
and baleen whales.
Mystacodon. Fast forward to the modern day, and baleen whales are some of the biggest creatures ever, currently the largest we have on our planet. Many evolutionary factors likely contributed to their size, but if you want to get big, you need to eat a lot. And being able to gulp down mouthfuls of food sure does help one when you're trying to bulk up.
Here the baleen is critical. It allows the whales to open wide and capture large amounts of food such as krill and plankton that get trapped behind their bristly baleen plates while seawater gets filtered back out.
So to understand how these whales got so big, it makes sense to go back to the first baleen whale. This must be the point in evolution when baleen really took off, right? Because baleen must have developed early in these creatures to help them get so big. Maybe, or maybe not.
Mystacodon is the first baleen whale, the holotype specimen from about 36 million years ago, but interestingly, it lacks direct evidence of baleen.
In fact, this creature had teeth, big ones in the back, small ones in the front, all of which showed signs of abrasion, like they had been scratched up by sandpaper.
Sand. That gives us a clue.
This fellow wasn't a filter feeder at all like our modern baleen whales.
Kai fun fact time! Dun, 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 dun. Teeth fossilize well, but baleen doesn't, since it's made of keratin, like your fingernails, and not bone. The earliest direct evidence of baleen in whales is about 11 million years ago, so scientists need to look for other anatomical clues that are associated with baleen.
These scratched up teeth are an important clue for scientists. Mystacodon may have engaged in suction feeding, capturing prey from the sea floor, sucking them up as it swims along. This suggests that early Mystacetes had diverse feeding strategies, not solely relying on baleen.
So, if it wasn't baleen and bulk filter feeding, what drove the diversity and gigantism of baleen whales that helped them get so big?
Well, the answer might be even bigger than our huge whale friends: changes in the ocean climate. About 34 million years ago, the Earth began cooling, and we see the emergence of the precursor to the Antarctic circumpolar current.
This powerful current churns up the ocean, bringing up nutrients from the bottom, making the ocean a more productive buffet of feeding options.
The evolution of baleen might be intertwined with feeding strategies that came about in response to these changes in the Earth's oceans. The early Mystaceti could have used teeth as a sieve, or maybe used both teeth and baleen at the same time. Alternatively, suction feeding might represent some kind of transitional phase between the bite and hold strategies of a predator with teeth to the more bulk filter feeding strategies we see in modern baleen whales.
As ocean productivity increased due to the Antarctic circumpolar currents, whales might have increasingly shifted toward bulk feeding, taking advantage of nutrient-rich conditions and plankton blooms.
Around 28 million years ago, diversity in feeding strategies leveled off, with filter feeding Mystaceti becoming dominant by 23 million years ago. So it seems that within 10 million years, these whales went from teeth-driven bite and hold feeding strategies to transitional suction feeding strategies with a mixture of baleen-like structures and teeth to full-on baleen filter feeding.
That is one fast transition, but a critical one that likely helped whales achieve their current massive size. Massive size! Whales are cool.
Competition, climate changes, new competitors further shaped the evolution of whales. But by around 3 million years ago, the larger ocean-going species became predominant, paving the way for the majestic baleen giants we love to see today.
Whales! But the question lingers, Why did these wolf-like creatures choose to return to the sea some 50 million years ago? Was it fewer predators, more abundant food, change in climate? What was it?
These questions really matter because scientists see changes in whale behavior happening today that are concerning. Today, whales are showing up in places where they really don't belong, and we really need to learn why and what it means for us and our planet.